This is a little video to discuss parameters for binomial probability distributions, talking about mean, variance, and standard deviation, and also to kind of sum up and review how to calculate binomial probabilities using the TI-84 Plus Silver Edition calculator. So parameters for specifically binomial distributions. First, to calculate the mean, and binomial distributions here, we're dealing with populations. So the mean is going to be mu, and that's equal to n times p. Remember, n is your fixed number of trials, p is your probability of success. The second parameter is variance, which is equal to sigma squared. And to calculate that, it's n times p times q. And remember, q is your probability of failure. And your last parameter is standard deviation, which, since it's a population, you're going to use the notation sigma, is equal to the square root of n times p times q. So pretty straightforward formulas. And so here's an example. In a Gallup poll of 1,013 randomly selected adults, 66% said that they worry about identity theft. Assume a procedure yields a binomial distribution. So the first question, since it's a binomial distribution, we're going to be finding the binomial mean. So to find the binomial mean, basically another word for that is the expected number. So to calculate that, its mu is equal to n times p. Well, n here, we have a sample of 1,013 adults, so n is 1,013, and we take that and we multiply that times our probability of success. In this case, that's 66%, which as a decimal is 0.66. We multiply those together, and we get 668.6. Remember, since it's a mean, we typically round to one decimal place past the data. So it'd be one decimal place here. And so what that means is if we have a sample of 1,013 people, we expect about 668.6 people to be worried about identity theft, the expected number. So second question, find the binomial standard deviation. Well, that's sigma. And to calculate that, that's the square root of n times p times q, which is equal to the square root of 1,013, that's n, times 0.66, that's your probability that someone is worried about identity theft. And to figure out q, that's always 1 minus whatever p is. So 1 minus 0.66 is 0.34. And from here, you type all this in your calculator, and you end up with 15.1, rounding to one decimal place. That's your binomial standard deviation. So question 3, use the range rule of thumb to determine a minimum usual and a maximum usual value. Remember, the range rule of thumb gives us a range of usual values. And what that says is that if you go out 2 standard deviations, so if you add 2 standard deviations and subtract 2 standard deviations, anything within those 2 numbers is going to be considered usual values. About 95% lie within 2 standard deviations. So to find the minimum, you take your mean and you subtract off 2 times whatever your standard deviation is. So your mean is 668.6, and you subtract off 2 times your standard deviation, which is 15.1. So you end up with 638.4, and that's a minimum usual value. To find your maximum usual value, you take your mean and subtract 2 standard deviations. You add 2 standard deviations. I apologize. And so that's 668.6 plus 2 times your standard deviation, which is 15.1, and you end up with 698.8, and that is your maximum usual value. So fourth question, if you randomly select 1,013 people, would the event of selecting 750 people who are worried about identity theft be an unusual event? Well, between 638.4 and 698.9, any number of people between those two numbers is considered usual. Anything outside that range of numbers is unusual. Well, 750 is greater than this maximum usual value of 698.8. So, if you have a sample of 1,013 people and 750 of them are worried about identity theft, that would be an unusually high number of people out of 1,013, since this number is greater than that maximum usual. And so that basically sums up parameters for binomial distributions. So below is just some more practice to calculate binomial probabilities. So dealing with this example, find the probability that exactly 650 people are worried about identity theft. So to calculate binomial probabilities, you're going to either use binomial CDF or binomial PDF, depending on the type of problem you're dealing with. So here we want to calculate exactly 650 successes, right? Exactly 650 people scared or are worried about identity theft. So here, solution, first you need to know N, right? In this case, we randomly select 1,013 people. And you need to know your probability of success. Well, the probability of success is equivalent to the probability that someone is worried about identity theft. In this problem, that's 0.66 as a decimal. So the probability that x equals 650, that you have exactly 650 successes, is equal to, in the calculator, you go second, open up that distribution menu by pressing vars, which stands for variables, and you scroll all the way down to binomial PDF. Press enter, and remember, first thing you need to type in is N, so 1,013. Your probability of success, if you randomly select one person, what's the probability that they're worried about identity theft? Well, 0.66. And then we're looking for exactly 650 people. So we're using, remember, binomial PDF for a precise number of people. Press enter, enter, and enter again. And you end up with 0.0123, rounding to 4 decimal places. So as a percentage, that's a little over 1%. So another example. Find the probability that at most 675 people are worried about identity theft. Well, at most, remember when you see the terminology at most, that means 1 or 2 or 3 or 4 or 5, all the way up to 675 people. Well, that means you would have to add up all those probabilities, and that would take a really long time. So the calculator adds up probabilities for us by using binomial CDF, right? So we're looking for up to 675 successes. So 675 people are worried about identity theft. So we're adding up all those probabilities. So we're looking for the probability that x is less than or equal to 675. So we're going to use binomial CDF. So second, open up that distribution menu, go all the way down to binomial CDF, which is right there. Press enter. Your number of trials, well, we have 1,013 people. Your probability of success in a single trial is 0.66, and your x value up to how many people? Up to 675. Press enter, enter, and enter again. So you end up with 0.6759, rounding to 4 decimal places. So approximately 67.59% if you would convert that to a percentage. And that's it for this video. Thanks.